Hi, in this chapter we're going to cover weathering and landscapes, geomorphology, geomorphic processes, weathering, mass movement, and coarse topography. So geomorphology is basically the study of the change in the landscape of the Earth, the study of landforms. Process, the action involved when a force induces a change, chemical, physical, in the Earth's surface materials. And then we have the idea of erosion. We've heard that term before, which is the movement of those, which will be discussed later. Lithology is the chemical and mineral composition of materials. And you can see the climatic conditions are critical controls of landscape development, solar radiation, heat, amount of timing of precipitation and whatnot, and when they come. If we have these events that don't come very often, they might have more of an impact if the land and the environment's not used to it. The initial landscapes, the endogenic processes build up on new material, and this high idea of dynamic equilibrium, which is the balance among force, form, and process. A lot of these times, these are going to be more pronounced in the western part of the United States than the eastern part, because we have a lot of, roots, grass, precipitation that'll redo or reinvigorate this process much more quickly than the western part of the United States, or drier areas which have less mechanisms for weathering and erosion. So geomorphology, delicate balance or equilibrium between landforms and processes that basically shape them. We have denudation, process that wears away or arranges landforms. Weathering, mass movement, erosion, which is basically your transport and eventually your deposition of materials. And these major agents are water, air, ice, gravity, which is always at work. So this is base level in Grand Canyon. This is what Grand Canyon looks like as a result of the water. This is a trip I took out to Utah. This is in the Colorado River, a little further upstream in Utah, outside the town of Moab. So you can see what you're looking at and what creates these with these base levels. Because eventually, even what we talked about with Mount Rainier, and if it were to flash melt, it wants to go down. That's what it wants to do. It wants to go down in some way, shape, and form. And if it goes down over a faster slope, we're going to have more runoff, erosion, or whatnot because of the faster water, as opposed to a more gradual, and that's going to take into account all the other factors. So we have this dynamic equilibrium when we approach this. Slopes, hill slopes are curved. We've got inclined surfaces. Strong slope, strength of materials is greater than the strength. And weak slope, the weak slope, the strength of materials is weaker than the strength of the denudation process, and which is unstable. And basically, gravity is going down faster than your frictional force, cohesion, the weight, and all these other things here. So we've got this very, very delicate balance between staying put and wanting to go down as a result of gravity. So we throw in things like an earthquake or other forces such as pyroclastic flows or water, which decreases this degree of cohesion here. A lot of neat things can happen. So we got a hill slope in disequilibrium, saturated, unstable soil. We have a lot of these in areas that receive lots of rains. So climatic conditions, places with permafrost. So there's a lot of interesting things that happen here, and it gets broken down by a number of different factors: decaying vegetation, soil development, root wedging, and whatnot. Frost, we know that water, when water freezes, it takes up a larger volume. So a lot of times you see cracks in the sidewalk that aren't supposed to be there. A result of water gets in there, it freezes, and basically this freezing, when it freezes, the atoms need to arrange themselves, which increase the volume a little bit. And it creates this frost action. Hydration, and then also some of the chemical weathering processes that we talk about. So you can see some of the frost action here when it cleaves or cuts a rock. And then we can see crystallization eroding at a weak point in a cliff face. We know that rocks weather at different rates. This is a picture of mine from Utah. You can see the La Salle Mountains in the background, but you can see these rocks are weathering away at different rates. And you can see, I think this is called Big Brother and Little Brother right here. This is another one that I took here in Arches National Park. Okay, and this is in sandstone, so you can see this has stayed, everything around it is basically weathered and erode transported away. Exfoliation, this is Half Dome in Yosemite. And then tree roots exert tremendous pressure on rock faces. It's very amazing what they can do. And then physical weathering along geometric joints within the rocks here. And you can see what happens here. So when these break down, basically, when this rock breaks down, you've increased the surface area, but the volume stays the same. So if this surface area increases and it's blown into the wind, it's got much more opportunity to break down other rock in these collisions with each other. And so a lot of interesting things happen. We're increasing surface area, but keeping the volume the same. So, energy can't, or matter can't be created nor destroyed, but when we change it from one form to the other, we are changing the surface area. So think about that a little bit and how it affects the overall weathering and erosion process. And this just kind of talks about that process. Hydrolysis gets into some of the chemical weathering processes, oxidation, carbonation, when it combines with materials such as water or oxygen, and different types of weathering here. Karst, this is limestone, and forms sinkholes. And then undersea, underwater, like caverns, under the ground. So you can see karst topography here. I believe this is in China, and we have it in the southeastern United States too. So these are some of these karst topographies. You can see one here. This is in Central America, the sinkhole. We see a lot of sinkholes in Florida. We've seen one in Missouri. But I thought this was interesting. I believe this is in Guatemala, Honduras. This one's, I believe, in Florida. You can see a house. And then caves, subterranean caves. We recently saw one in the news in the summer of 2018 in Thailand. And then we have subterranean caves, and we have a lot of these in Western Virginia. And the cave formations, stalactites, stalagmites, and then we have mass movement. Okay, so this just talks about some of the terms, the angle of repose, this delicate balance between friction and gravity and cohesion and forces wanting it to go down versus staying in the same place. And then what are some of these external factors that are going to make that happen? And then soil creep, something that occurs over an extended period of time. And then these are some of your mass movements, your earth flows, your rock slides, your rock falls, your creeps, and then talus. This is Devil's Tower in Wyoming. This is a picture of mine here. Basically, this is an old volcano, and the volcano has eroded away, but this is the middle of the volcano. It's called a plug. And so you can see the mass wasting right there. Okay, of all of these are about 10 feet wide that have fallen in the past and broken up. Okay, so just the effects of gravity, the long-term effects of gravity, as opposed to some of the short-term effects of gravity. Landslides, this is one in Mexico in 2010. This is mass movement in New York City. Okay, you don't want to mess with gravity. Then human-induced mass movements. Cutting into hill slopes, strip mining, broken water pipes are all causes of some of this mass wasting. Logging in Montana, and like I said before, here we log this area here, we log this area here. It increases the amount of runoff because there are no more trees that require that water. And you can see some in karst regions in southeastern Alaska.